Hello everyone, this is Salman sir here, and now I am going to introduce 7th video of chapter solution. In this video we are going to calculate the value of want-Hoff factor. Want-Hoff factor will be useful, will be important, because if the value of I will be put into all 4 formulas of colligative property, the abnormal molecular mass become normal. Now, if association takes place, when we add non-volatile solute into volatile solvent, there is 3 chances. Either it will associate or it will dissociate. And third chance is neither dissociate nor associate. If association takes place, the relation between alpha and I will be I is equal to 1 minus alpha plus alpha by n, where alpha is degree of association. If 20% association takes place, the value of alpha will be 0.20, and where n is the number of molecule associated. For example, benzoic acid, 2 molecule of benzoic acid associated, 2 molecule of benzoic acid dimerizes, so the value of n will be 2, right? For dissociation, alpha is equal to I minus 1 upon n minus 1. Alpha is here, we will say degree of dissociation, and by the same method we will calculate the alpha. If 100% dissociation is given, the alpha will be 100 upon 100 is equal to 1. If 90% dissociation is given, the alpha will be 90 upon 100, it will be 0.90, where n is the number of ions formed. Suppose we are adding electrolyte sodium chloride as a non-volatile solute. It formed 2 ions, sodium ion and chloride ion. So the value of n will be 2. If you will add magnesium chloride, it formed 1 magnesium ion and 2 chloride ion. The value will be of n will be 3 because 3 ions form. In case of ferric chloride, 3 chloride ion and 1 ferric ion will form. So total number of ions will be 4. The value of n will be 4 here. In case of potassium ferrocyanide, 4 potassium ion and 1 ferrocyanide ion is formed. The total 5 ions are formed, so the value of n will be 5. If you will put the value of n and alpha into this formula, you will get the value of I, right? If you will put the value of n and alpha into this formula, you will get the value of I here for association. So in the numerical, it will be mentioned the molecule non-electrolyte solute what we are going to add into volatile solvent. It either dissociates, then this formula will be used to get the value of I, or associate, then this formula will be used. And in third case, it will neither be dissociated nor associated, for example, glucose and urea. In that case, the I will be equal to 1.